Hi, my name is Luca Ferranti, and now I will talk about RangeEnclosures.jl, a flexible API to bound function ranges. So here is a quick start example. Suppose we want to bound this function over the interval -10, 10. The main beef of the package is the function enclose, which takes as input the function and the domain, and it will return a rigorous enclosure of the function range. And by default, it only simply evaluates the function over the interval with interval arithmetic. And this in general gives quite disappointing results, but it also offers several algorithms to give tighter enclosures. For example, using branch and bound algorithm, we can actually get a very tight enclosure of the function. In general, the algorithms can be divided in two types: direct methods, which evaluate the function over the interval in a single pass, so to speak. So here we have a few examples: natural enclosure, which is a simple plain interval arithmetic, and mean value form, a different algorithm. And as we can see, in this case, neither is better than the other. They are overlapping. And so we can also pass a vector of algorithms, and the enclosed function will bound the range with each algorithm and return the intersection, which is in this case tighter than either result. Direct method in general are not tight, and so we also have iterative methods whose idea is to divide the domain in smaller intervals and evaluate the function over each smaller interval with a direct method. We saw before the branch and bound, which is an iterative method. Another one is the Moore's-Kalbu algorithm, an interval global optimization algorithm, which computes the global minimum and global maximum rigorously and hence the range. And note that we need to import interval optimization to use this algorithm because it's implemented in another package. Finally, everything I showed also generalizes to multivariate functions, with the difference that now the function has to take a vector instead of a single number as input, and the domain now it's not an interval, but an interval box. Otherwise, we can still pass the function, the domain, and the algorithm which we want to use, and will compute an enclosure, like in this example. Thank you for listening, and if you have any questions, I would be glad to answer them.